So, quick honesty before we start. I have to ask if you know the true nature of the two voices about to, well, explain AI to you.
Right. The fact that we are ourselves AI.
Yes, exactly. But, a real person actually did the research and wrote every single word.
Yeah. He really does not have the radio voice for it.
Right. So machine voices, human mind.
Carry on. Welcome to Plain Strata, where we take decentralized AI apart, one layer at a time.
Glad to be here.
So this is a Pulse, which is our weekly look at the field's one real story. And today is about what an open AI model actually costs to run.
Because the real cost is definitely not what people think it is.
No, it's really not. So let's drop right into what happened.
Yeah.
Imagine it's July 27th. You wake up, you log onto the internet, and there's a 1.56 terabyte folder just sitting there.
Just a massive file.
Huge. A lab in Beijing, Moonshot AI, they put the full weights of Kimi K3 right on the internet. And Kimi K3 is the largest OpenAI model ever released.
Right, the largest by far.
Yeah, and they told the world that anyone could have it. It costs absolutely nothing to download. The folder is 1.56 terabytes, and the license is permissive enough that you could, build a whole business on it.
But there's a catch.
The biggest catch.
Yeah.
Almost nobody on Earth has the hardware to actually run it.
Which brings us to the spine of our story today. The gate on an open AI model was never the license. The gate was always the memory to hold it. But this week, a network of strangers pooling together ordinary gaming cards, they claimed to move that gate entirely by software rather than new silicon.
Which is wild.
It is. And doing that, moving the gate with software, immediately made checking what those strangers actually ran part of the exact same product.
We are definitely going to return to that checking part, but we need to unpack that 1.56 terabyte folder first.
We do.
Because if it's completely free, people are going to wonder why they can't just download it to a normal hard drive on their desktop and fire it up.
Exactly. We have to establish the physical constraint here, because that constraint is what makes this whole hardware rebellion matter.
So a model's weights, they are fundamentally just numbers.
Yes, just billions and billions of numbers. We call them parameters. And if you look at the root of that word, it comes from the Greek para, meaning beside, and metron, meaning measure.
Beside the measure, so it's like a setting.
That is a great way to think of it. It's a setting that shapes an outcome without being the outcome itself. It dictates how strongly one small piece of the neural network pulls on another piece when it's processing information.
Okay, got it.
And Kimi K3 has 2.8 trillion of them.
Wow. 2.8 trillion.
Yes, and the physical grounding here is just brutal because to answer a single question, just to generate even one word, all 2.8 trillion of those numbers must sit in extremely fast memory.
Right.
And that memory has to be attached to a processor at the exact same time, not on a hard drive and not streamed.
Wait, so I can't just stream it. Is this like trying to stream a massive 4K movie on a bad connection where I just watch the first minute while the second minute downloads?
No, actually streaming comes in chunks. That is exactly what you can't do here.
Oh, I see.
Think of it more like a massive stage play. You need every single actor on the stage in their exact positions at the exact same moment before the curtain can even go up.
So every single number has to be ready.
Right. All 2.8 trillion numbers have to be present and resident in memory before the first word is generated. You can't fetch them from a hard drive on the fly because the processor would just starve while waiting for the data.
And the specific memory required for this, it has a name, doesn't it?
It does. It's called high bandwidth memory, or HBM.
Okay, HBM.
Yes, and the physical architecture HBM is what makes it so special. It's physically stacked in these vertical towers and soldered just millimeters from the math processor.
Millimeters. So it's incredibly close.
Exactly. So the bytes physically don't travel far. That's what allows the processor to ingest those trillions of numbers at lightning speed. But serving Kimi K3, it requires roughly 64 data center accelerators packed with that HBM.
64 of them.
Yes, and if you're renting them, you are looking at up to $500,000 a month just in fees.
So let me get this straight. The open license says, please help yourself to the model. But the physical hardware reality says you can only help yourself if you have $500,000 lying around every single month.
That is the true gate. The permission is completely decoupled from the physical capacity. And since data center HBM is a $500,000 gate, it created this massive incentive for someone to try and pick the lock.
Which leads us right to the very next day, July 28th. A group just comes out of nowhere and claims they had the entire Kimi K3 model serving on 80 RTX 5090 gaming cards.
Right.
And these are cards you could theoretically just buy at a standard computer shop.
Yes, the consumer gaming cards. But the underlying network they used to do this is crucial. They did this on Bittensor.
Bittensor, right.
For those who haven't heard of it, Bittensor is a decentralized network. Anyone can plug in their own machines and get paid for doing AI work.
So there's no central company deciding who gets to join.
Exactly, no central authority. And within that network, they use these things called subnets. A subnet is just one specific set of machines on the broader network, and they're all running the exact same job.
Okay, so who are the specific players here?
The ones who made this announcement, they operate on subnet 53, which is called NG, and they're managed by a team called Hanlon AI.
Got it. But, the hardware reality of this claim is what really gets me. Those RTX 5090 gaming cards, they don't use that exotic stacked HBM you were just talking about, right?
No, they don't. They use GDDR7, which is ordinary board-mounted memory. It is significantly slower per card than data center memory.
But you can actually buy it.
That is the major advantage. There's no massive corporate waiting list where you have to beg a hardware manufacturer to sell to you. Hanlon AI even published their exact setup. They used 10 nodes, and each node held 8 of these gaming cards.
And they connected all these boxes using 25 gigabit Ethernet.
Yes.
Wait, I need to do the math on this. Why 80 cards exactly?
Just simple math, really. 80 cards at 32 gigabytes apiece gives you 2.56 terabytes of total memory.
Okay, and the model was 1.56 terabytes.
Right, so it comfortably fits the Kimi K3 model. It roughly matches the capacity of 32 waitlisted data center cards, but it's built entirely from parts anyone can buy today.
But I'm stuck on the networking part. 25 gigabit Ethernet is just standard fast office networking. It's the kind of stuff you use to connect servers in a normal corporate IT closet.
It is very standard.
Right. It's not the exotic ultra-fast cluster fabric you see in supercomputers. So how on earth does a model spread across 10 different machines over standard office cables, not just crawl to an absolute halt?
The secret there is the structural shape of the model itself. Kimi K3 is a mixture of experts.
A mixture of experts.
Yes, that specific architectural pattern is what makes this entire hardware rebellion possible.
Wait, is this like a massive university? Like, imagine you have thousands of professors on staff covering every topic, but when a student walks in and asks a question about biology, the entire faculty doesn't need to show up to the lecture hall.
Right, only the biology professors.
Exactly. Only the 3 biology professors wake up to answer it, and the rest of the university stays asleep.
That is a perfect level 2 analogy. In technical terms, while all 2.8 trillion parameters must be physically present in the memory pool, only a tiny fraction of them are actually active at any one time.
Really? How many?
When Kimi K3 processes a word, a routing mechanism decides which experts need to handle it. So out of 2.8 trillion parameters, only about 100 billion do any heavy arithmetic on a given word.
Oh, wow. So this splits the fundamental problem completely in two. Capacity is one problem, and arithmetic is another.
Exactly. Capacity is incredibly expensive in the data center, but the actual arithmetic required per word here is relatively small.
So cheap gaming cards are perfect for just holding massive amounts of capacity, as long as you don't need all of them doing heavy math at the exact same time.
Precisely. If you tried to run heavy, sustained math across all 80 cards simultaneously, they would overheat and the bandwidth would choke. But they are perfectly adequate as a giant passive bucket of memory for a mixture of experts model.
But there has to be a penalty for chopping the model up across 10 different physical boxes, right?
Yes, there is. It is the Ethernet tax.
Ethernet tax.
Yes. Because the model is chopped up, each word has to literally walk across the network cables, going through pieces of the model living in different physical machines.
And if you did that over the open internet?
It would fail completely.
Yeah.
The slow wire would turn those expensive graphics processors into machines that spend 99% of their time just waiting their turn for data.
But because they did this over 25 gigabit Ethernet, all within a single building, it becomes a manageable tax.
Exactly. They stepped over the wall instead of breaking it down.
They found a low spot in the memory wall and just used office equipment to step right over it.
And they could only step over it because that mixture of experts architecture severely limits the arithmetic needed per word. But, this brings us to a really massive, glaring problem.
Which is?
We just established that serving a giant model on cheap hardware technically works. But doing this on a decentralized network with absolute strangers creates an overwhelming temptation to cheat.
Yes, I was just thinking about this. Because, if I'm just some anonymous person running a node on this network, I have a massive financial reason to cut corners.
You do. Running a 2.8 trillion parameter model takes a lot of electricity.
Right. So what's stopping me from just swapping in a much smaller, cheaper model, letting it generate the text, and then pocketing the difference in electricity costs?
Nothing physically.
And the person asking the question might never even notice, right? The text often looks pretty much identical.
This is exactly why the product Hanlon AI and the NG subnet built is not actually cheap serving. They built checked serving.
Check serving.
Because cheap serving from an anonymous stranger is completely useless if you can't trust the output.
Okay, so how do they actually check it? I mean, how does the network know?
You have two roles. First, the machine's doing the work, which the network calls miners. Right, they run the full Kimi K3 model. But crucially, they don't just spit out the final text answer. They have to commit to a record of what happened inside the model while it was running. They prove the internal state.
Okay, and then you have the machines watching them?
Yes, the validators, they are doing the scoring. The validators take slices of that internal record from the miner, and they audit it against a mathematical signature tied to the exact bytes.
Wait, is this like a bulletproof cryptographic guarantee?
Yeah.
Like a zero-knowledge proof where we mathematically know for absolute certain that no cheating happened?
No, it's not a perfect cryptographic proof. Generating a perfect proof for a 2.8 trillion parameter model would be astronomically expensive and extremely slow.
So what is it then?
It sits just outside a cryptographic guarantee. It's much more like a spot inspection, but with real money on the line.
So it's a probabilistic audit. The validator just checks a random slice of the work, and if the miner's caught lying, they lose the financial stake they put up to join the network.
Exactly. It raises the cost of cheating high enough that it is no longer profitable to fake the work.
Which really brings the core takeaway to the surface here. In a decentralized world, cheap hardware and checkable output are the exact same product.
They have to be.
Right, because without the checking mechanism, you haven't built an open alternative to the big tech data centers.
Yeah.
You've just built a lottery where you hope the stranger on the other end is feeling honest.
The moment the machines running your model belong to strangers with the financial reason to cut corners, the checking is the only thing that makes the cheapness usable.
It's fascinating.
It is, and this dynamic leads us directly into a historical pattern. We really need to contextualize this breakthrough.
Because it's not just about a single crypto network claiming a hardware trick, is it?
No, it's about the historical shape of how access to technology actually works. Let's name the cross-domain pattern out loud. It is permission without capacity.
Permission without capacity.
Think of the journalist A.J. Liebling back in 1960. He famously said that freedom of the press is guaranteed only to those who own one.
Oh, that is a perfect analogy. The legal permission to print a newspaper was universal, right? Everyone had the right to do it.
But the physical printing press itself was incredibly expensive.
Right, it was concentrated in the hands of a few wealthy publishers. So the permission meant absolutely nothing if you didn't have the physical capacity to exercise it.
And every single generation of this pattern looks exactly the same. Open weights and AI are the exact same pattern, just with silicon replacing the printing press.
So the open license from Moonshot AI, it democratizes the digital file. It makes Kimi K3 free. But the permission means nothing without the capacity, the $500,000 of HBM memory to hold it.
Exactly. And historically, when permission outruns capacity, someone always builds a way to pool the capacity together. Today, it's a permissionless network like Bittensor, allowing strangers to pool gaming cards to replicate a data center.
But, we need to pivot to the raw reality here. This is where we take the honest cut. We can't just leave these facts unchecked.
No, we have to look at the reality.
Because nobody outside of Hanlon AI has actually reproduced these numbers yet.
That is a critical caveat. No independent benchmark exists yet. And frankly, 20 tokens a second on a single stream is quite slow for a real production application.
Right. It's slow. And furthermore, the subnet's own token is up roughly 300% in a month. So there is real significant money driving this loud announcement.
Yes, there is a clear conflict of interest. Our standing rule applies perfectly here. A company-reported result becomes actual evidence only when somebody outside the company reproduces it.
Until then, it's just a claim.
It is.
But synthesizing all of this, none of those caveats inherently make the claim false. It just makes it unverified. But if it does survive contact with reality, the implications are staggering.
They really are. It means the gate on the largest open model in the world moved entirely via software and a clever serving strategy. No new silicon was manufactured.
Right. No new multi-billion-dollar fabrication plants were built. It was achieved strictly through software, a serving strategy, and a mechanism to check the strangers running it.
And access built this way is literally access through strangers. The entire arrangement rests completely on that checking mechanism being good enough and cheap enough to run constantly.
So we want to leave you with a final provocative thought, something to really test this whole narrative. Because the true test here isn't just a single demo video.
No, the true test is whether anyone reproduces this 80-card configuration under real concurrent load.
Right, because serving one single user at 20 tokens a second is vastly different from serving thousands of simultaneous users who are just bombarding the network.
Exactly. Watch to see if other decentralized inference networks start announcing Kimi K3 hosting in the coming weeks. This specific model is the ultimate stress test of whether these networks can actually serve models that nobody can afford to self-host.
That was the why. The how is the rest of the show. And no background is needed. If you can follow a story, you can follow this. This is plain Strata. Decentralized AI layer by layer.